Sometimes in absolute value equations, there are no solutions or there is only one solution. All the absolute value equations we've been looking at have had two solutions. We've gotten to a point like this, we've said, oh, because this absolute value will make this number positive no matter what, what's in here could be negative, this number, or it could be positive, this number. And we've done that all along, and we've ended up with two solutions as a result. Now, there's a couple situations you could find yourself in where there wouldn't be two solutions. So, there's no solution to an absolute value equation if the absolute value of a number is negative. Okay? Because here's the thing. We know what absolute value does. It makes numbers positive. So there's no number that I could put here in the absolute value sign, and the absolute value of that number would be -5. It's impossible because the absolute value makes numbers positive. So here, if I see something like this, that the absolute value of a number is negative, anything negative, I would just right away say, oh, that does not have a solution. There is no value for x that will make this a true equation. Okay, so let's say I'm working on solving like this. I realize, oh, there's an absolute value here. I'm going to subtract 10 from both sides, get the absolute value by itself. And when I do get the absolute value by itself, on the other side of the equation is a negative sign, a negative number. Right here, I would say, oh, this absolute value equals something positive, negative. There is no solution to that. There is nothing that I can put inside this absolute value sign that would make it equal -8, right? Because absolute values make things positive. So here I would put no solution. Here's another situation. The absolute value of a number is 0. If the absolute value of a number equals 0, well, then you could even almost think of it as like, oh, well, I break this up into two solutions, the negative n is -0 and n is +0. The thing is, there is no negative and +0, right? There is just 0. So in this case, this would just be n equals 0, and it only has one solution, not our usual two solutions. Okay, so again, like let's say you get an equation and you're solving it and it looks like this. And you're trying to get the absolute value by itself. -4 plus 4 is 0. And we divide by 5. And I realize, oh, this is absolute value is going to equal 0. Well, when I go to think, well, I'm going to split it into two equations, there is in fact only one equation, right? Because there is no negative and positive 0. They're the same. So I get x equals -1. This would just have one solution. Okay, and then the last possibility is the one we've been working with, which is the absolute value of a number is positive. And here is where we actually split it into two solutions, because the thing is that because absolute value makes a number positive, this p could actually be a -10, and the absolute value is making it positive, or it could be a +10, where the absolute value sign isn't playing any role. So in this situation, this is like the ones we've been working on. There's two solutions. Here's an example where I realize, oh, the absolute value equals a positive number. So I say, oh, 4x equals -16, or 4x equals +16. And here I end with two solutions, kind of like I've been doing all along. Okay, so this would be x equals -4, +4, right? And this is two solutions, which is like, you could almost view this as like the normal situation. This is what we've been working on. But there are these other situations where there might only be one solution if the absolute value equals 0, or there may be no solution if the absolute value equals a negative number.